One of the most important aspects of networking is data encapsulation, where a user-based application actually begins to use the network. For example, here we have the sender of data. We're using a word processing application that is actually accessing a database server to grab some data from another location on the network. The sender of the request is going to have to now utilize the network stack or the network components on that computer to be able to access the physical media to get to the destination of this conversation on the network. What the sender will do is that he will actually take the original application data, which becomes user data, as you can see above the application layer. Now remember, whatever happens on and below the application layer is all based on function. That is, the function of the operating system that this computer is running, and the function of the network components that are actually running on this computer. For instance, the protocol or the network interface card that this computer is using. Nonetheless, the user data is actually passed down to some area in the operating system, which is going to provide access to the network components. Here, that user data is passed down to the function at layer 7. At layer 7, any information that is required for layer 7 to do its job, for example, to perform user-based authentication or possibly synchronization of peers, whatever is necessary, is added to the header to the original user data. This actually becomes data that will be passed down to the next layer in the network stack, which is the function of layer 6. Now at layer 6, a layer 6 header is added to the data. Now keep in mind that even if something does not need to change, we will always have this header being added to the existing data, and thus every single packet is going to look the same. In this case, let's say that there was some decoding that needed to take place between the user's application and the destination component, possibly a database server. So any information necessary in layer 6 to do the decoding would actually change in the header. This would then become data that will be passed down to layer 5, where my session can now be established with the target. Layer 5, or the session layer, will set up, maintain, and finally terminate my session once I'm through with my conversation. The layer 5 header is added, and this data is then passed down to layer 4, where typically some sort of port is utilized to access the target application or establish the connection between the two applications. The layer 4 header becomes data to pass down to layer 3, where routing and addressing occur. The layer 3 header will typically contain any information about the source and the destination addresses, and any routing information which is necessary to get this individual unit of data to its destination. This packet, the layer 3 information, gets added to the remainder of my data, and my data is finally passed down to the data link, or layer 2, where this data is going to be framed. Now, two very important things happen in layer 2 during this framing process. First, a layer 2 header is added to the existing information. The layer 2 header is going to contain a special set of addresses, which are known as MAC addresses. Both the source, which is the sender, and the destination, which will become the receiver in this particular conversation, are added to this layer 2 header. This is a way for the receiver to actually identify that this package is in fact destined for them. Also, at the end of this frame, we're going to have a typical component which is added. This component is known as a trailer. In this case, it is referred to as the frame check sequence, which is very accurate. This indicates nothing more than the mathematical computation of the information beginning with the layer 2 header all the way through the user data, which originated at the very top of my application. This mathematical computation allows an integrity check to be performed on the opposite end, once the frame itself is received for verification purposes. If the frame was received intact and without damage, then there was no corruption on any of the data bits. This is very important for ensuring the reliability of our networking from end to end. Note that framing will be very different for every protocol that we intend to use. Also keep in mind that framing will be slightly different for each network media type that we use. Once the framing process is complete, we will then convert the data into physical bits. The positive and negative charges of electricity, which are going to be sent across the physical wire. This is done by the physical layer, which will also provide any clocking of the line which is necessary to make sure that those bits themselves are sent at the proper speed in the proper order and can be properly received.